In 2026, the United States ran into a problem that even the world's largest military budget could not immediately solve. It needed more missiles. Recent conflicts had consumed large numbers of American precision weapons and air defense interceptors. The obvious solution seemed simple: build more. The Pentagon placed larger orders. Defense companies announced new production lines. Billions of dollars began flowing into factories and suppliers. But there was a problem. You can fire a missile in seconds. Replacing it can take years. America has the money, it has the technology, it has the largest defense budget in the world. So why can't it simply make more missiles? Because a missile is not just a weapon. Behind every missile is a factory. And behind that factory is an entire industrial system that cannot expand overnight. Imagine the Pentagon suddenly decides it wants 10 times more missiles. The money can be approved relatively quickly. The missiles cannot. A modern missile may need a rocket motor from one company, guidance electronics from another, explosives from another, and specialized sensors, chips, and metals from dozens of suppliers further down the chain. Almost every component can be ready. But if one critical part is missing, the missile still does not leave the factory. This is similar to what happened to car makers during the global semiconductor shortage. A manufacturer could have the engine, body, wheels, and seats ready, but without one small chip, the entire vehicle remained unfinished. Military supply chains can be even harder to expand because many of their components have almost no civilian market. A company making ordinary electronics can sell to thousands of customers. A company producing one specialized missile component may have essentially one major customer: the US government. That makes it expensive to maintain huge factories and idle workers just in case a war creates demand years later. And one of the clearest examples is hidden inside almost every missile: the rocket motor. A solid rocket motor provides the enormous burst of energy that sends a missile toward its target. But building one reliably is highly specialized work. The propellant has to remain stable for years. The casing has to withstand enormous pressure. And after sitting in storage, the motor still has to work immediately when needed. For years, the American solid rocket motor industry became concentrated among only a small number of major suppliers. That is manageable when demand is predictable. It becomes a bottleneck when the Pentagon suddenly wants thousands more missiles. The US government is now spending heavily to expand production and bring additional suppliers into the market. But adding another supplier does not instantly double output. You need a facility, specialized machines, trained workers, testing and approvals, and the new production process has to prove that every motor is reliable enough to use inside a weapon. So even if Washington decides today that it needs far more missiles, the physical answer may not arrive for several years. The Patriot system shows what this means in practice. Patriot interceptors have become some of the most important air defense weapons in the world, but every time one is fired, it is gone. And during an intense missile attack, interceptors can disappear much faster than factories were designed to replace them. The United States is now trying to dramatically increase production. Current plans aim to push annual production capacity for PAC-3 interceptors from roughly 600 toward around 2,000. THAAD interceptor capacity is also expected to rise several times over. Those are enormous increases. But they do not happen tomorrow. Factories have to expand. Suppliers have to expand with them. And some of that new capacity will not arrive until years after the demand appeared. That gap is the problem. A military can consume years of factory output during one intense conflict. The factory cannot suddenly produce years of missiles in a few weeks. Tomahawk cruise missiles reveal the same problem. For years, the United States bought relatively modest numbers of them. That made economic sense. Why maintain capacity for 1,000 missiles a year if the government only plans to buy a fraction of that? Now, the Pentagon wants production to increase dramatically. But before 1,000 missiles can be built, the ability to build 1,000 missiles has to exist. Machines have to be installed, workers have to be hired, suppliers have to scale. And some missiles ordered today may not reach military inventories for several years. Washington can approve the money this year. The physical missile may arrive much later. That is the difference between money and production capacity. So why didn't America build much larger factories before the crisis? Because during peacetime, that looks wasteful. Imagine a defense company spends billions expanding a missile plant. It hires hundreds of workers and buys specialized equipment. Then the conflict ends. Government orders fall. Now the company owns an expensive factory operating far below capacity. Workers still need salaries. Machines still need maintenance. Defense demand has historically moved in cycles. A war begins. Orders surge. The war ends. Orders fall. So companies have a strong incentive to build only as much capacity as they expect the government to support for years. That creates a system that looks efficient during peacetime, but it creates a weakness when war suddenly begins. Unused factory capacity looks wasteful until the moment you need it. Then it becomes priceless. This is why the Pentagon has increasingly turned to multi-year contracts, instead of simply telling a company, build more missiles this year. The government can promise to keep buying them for years. That gives manufacturers a reason to expand factories, hire workers, and invest in suppliers. And that represents an important change. The Pentagon is no longer just buying weapons. Increasingly, it is buying the ability to make weapons. Even bigger factories, however, do not solve everything, because an American missile does not necessarily depend only on American materials. Modern weapons use specialized metals, chemicals, rare earth components, and microelectronics drawn from complicated global supply chains. Some of those supply chains still rely heavily on overseas production. So a missile may be assembled in the United States, while one critical material inside it comes from thousands of miles away. Replacing that supply takes time too. New mines and processing facilities can take years to develop. Materials have to meet military standards, and supply chains that moved overseas over decades cannot simply be recreated in months. The missile is only the final product. Behind it is a much larger industrial network. The war in Ukraine had already exposed this mismatch. Artillery shells and air defense weapons were suddenly being consumed at rates Western defense industries had not seen in decades. The United States invested billions to raise output. Production increased significantly, but not overnight. Ukraine revealed the basic problem. Wars can increase demand almost immediately. Factories respond over years. And the same pressure is now appearing in missiles. Defense companies are not struggling to find customers. They are struggling to expand quickly enough to satisfy them. There is another question America is being forced to reconsider. For decades, U.S. military technology focused heavily on making each weapon more capable. Longer range, better sensors, higher precision, more advanced guidance. That produced some of the most sophisticated weapons in the world. But sophistication comes with a cost. The more complicated a weapon becomes, the more expensive and difficult it can be to manufacture. And modern battlefields increasingly contain very cheap threats. Drones, low-cost missiles, mass-produced unmanned systems. That creates an uncomfortable problem. It does not matter how capable an interceptor is if you cannot build enough of them. So American planners are increasingly talking about a high-low mix. Keep some extremely advanced weapons, but combine them with cheaper systems that can be produced in far greater numbers. That represents an important shift in thinking. For decades, the question was, how good can we make the weapon? Now, another question matters almost as much. How many can we make? This becomes even more important when the United States thinks about a possible conflict in the Pacific. Distances there are enormous. Aircraft and ships may have to strike targets from hundreds or thousands of miles away. That makes long-range precision missiles extremely valuable. But those are often the same weapons that are complicated, expensive, and slow to replace. This does not mean America has no missiles left. It does not mean the United States cannot fight. Production is already expanding. New suppliers are entering the market. Factories are being upgraded. The deeper issue is what happens if a major war lasts far longer than expected. The opening phase depends heavily on what is already sitting in storage. A long war depends on what the country can keep producing, and that requires industrial capacity built before the crisis begins. For much of the last several decades, the American economy optimized for efficiency. Keep inventories low, avoid unused factories. Outsource when someone else can produce something more cheaply. Build only as much capacity as customers are expected to need. Those ideas work extremely well for ordinary businesses. National defense is different. A factory that looks unnecessary for 20 years can become essential in 20 days. That is why the United States is now investing directly into the industrial base behind its weapons. Longer contracts, more suppliers, more production lines, more cooperation with allied manufacturers, and more weapons designed around the ability to produce them at scale. America is responding, but industry operates on a different clock than war. Money can move quickly, orders can move quickly, factories cannot. Eventually, someone has to build the plant, someone has to manufacture the rocket motor, and someone has to process the materials, someone has to assemble and test the missile. And those things happen on industrial timelines. Military power is not just the weapons already sitting in a warehouse. It is the ability to replace them after they are gone. A missile can be fired in seconds. A stockpile can be depleted in months. But the factories behind that stockpile can take years to expand. America has the money, it has the technology. What it is rediscovering is something much older. Factories matter, because in a short war, the country with the best weapons may have the advantage. But in a long war, the winner may be the country that can still build them. On day 100,